My name's Kelli Bassett. I'm an agronomist with DuPont Pioneer. I've been covering Central Illinois for several years with all the crops that DuPont Pioneer supports, and have just moved into a role this week supporting primarily soybeans and a little bit of wheat. So if you are familiar with that crop up here, I'm not sure there's very much of it grown. Down south where I am at, I live along Interstate 70, and folks like to remind me that wheat is called poverty grass in that area. So I know I'm out of my territory when I say that, but please don't take offense to that. But again, welcome. I've had the opportunity to speak here with the group before. I think Lance and I had a topic a couple of years ago. So welcome back if you've heard me before over at Bloomington, I believe it was. Appreciate the support for ISA and the event today. My topic is pretty broad as far as the topic title. I did throw another word in there, agronomic and genetic gain, so that I could focus on a few things that are coming from the company that I work for, as well as some of the research that we've done. If you haven't already picked up one, I've got these handouts right here. There's a nice booklet. There should be enough for everybody, but you might have to grab one at the end of the aisle. I'll reference a couple of the things in here. These are the summaries of research done on the farm and in the field from across the company in, I think, pretty much North America. You'll find stuff from all over the U.S. Represented in this, and I had a couple pieces that I represent or reference up here, so I thought you guys might like a copy of that. So what I'd like to go into from perspective of how we meet the global challenge for soybean demand. We talked in our last group about how that's growing. Productivity improvements in soybeans, the environmental types experienced in Illinois, solar radiation, why it matters and how you can adjust that to improve soybean yield, AYT 4.0, which is something from Pioneer, our next generation of beans, and then also something to enhance the soybean oil market. So that's the outline of things that we'll cover here. How are we going to sustainably grow more soybeans on potentially less arable land? When you look at this chart showing the growth of population, which is the black line, you can see it's predicted to grow exponentially at the far right-hand side. And then the line that's green is showing the amount of arable land, and it's not really growing, but it's declining. And the reason it's declining is because we have continual development occurring, right? So we're not going to gain any more ground. So that area in between is what we're tasked with, and the reason we're all here today is to try to understand how we can grow more soybeans on less land in an agronomic way with genetic and agronomic gain. So I'll talk a little bit about some of the things that I see as additions to this. When we look at both corn and soybeans, this chart goes back to 1985 all the way out to 2015, and sometimes there'll be a comment that says, you know, I don't think that soybeans are gaining as much as corn on a per bushel basis. Well, if you look at them on a per bushel basis, that's correct. But if you look at them on a percentage basis, you can see over time, this red bar are soybeans, and you can see the yields on average across the U.S. They are growing, but soybeans being the red line and corn being the blue bar, on a percentage basis, they are keeping track. Corn at 143% and soybeans at 141%. So we are tasked with trying to make this line steeper and make that gain go up faster in order to meet that gap that we talked about in the last slide, right? I mean, that's why we're here. From your perspective, if you're a grower, to increase production, to increase your bottom line, and to meet that demand that we're talking about. So if we look at this, as I mentioned, our task, trying to make that line steeper and see where that goes. Now we talk in the industry, well, where is that going to come from? Where are we going to see that increase in yield to meet the demand? Is it going to come from the genetic side, or is it going to come from the agronomic side? Well, I'm not a soybean breeder, I'm an agronomist. So if I was in a room like this, I'd say, well, I think 51% of that gain is going to come from the agronomists and management things that farmers put in place. And 49% will come from the breeders. Fair? However, if I'm standing as a breeder, it might go the other way. And the breeders might say, no, we're going to be charged with the 51%, and you guys can take credit for the rest. But either way, we have to work together from that perspective with the new technologies and the things that are coming from the breeding perspective, along with the management approaches that we have that we can implement in the field. So this came across my desk just a couple of days ago as a broad scale email to Pioneer and Pioneer customers and whomever else. Top 10 things to do to improve soybean yield. Well, I think as a group we can agree that these are the top 10 things. And these are the levers that you push and pull to increase soybean yield as a whole. And depending on which one you manipulate or adjust, it may provide more or less potential for more yield than another one. But the foundation being variety selection, seeding rate, planting date I'm going to talk a little bit about, stand establishment, which goes hand in hand, spacing, soil fertility, I think that's another topic covered here today, and then the management of the last 4 things being disease, insect, soybean cyst nematode, and weed management. And I won't get into all of these because I feel that there are a lot of other experts here that are going to talk about more of these things. And we, as I said, we can adjust a lot of these to influence our final soybean yield. This map is called an N-class map. I don't know if anyone in the room has ever had this put in front of them, but it's the environmental classifications of the weather felt across North America, primarily the United States and Canada. And for those of you kind of on the outskirts of it, if you can see, if you key into Illinois, there's a really pretty green. Somehow that's, in my mind, a Pioneer green on it, and I didn't plan that, but that's how the company does it. And that corresponds to what's considered a temperate environment felt across Illinois. This is the 50-year average. So over the course of 50 years, the environment experienced in Illinois will ebb and flow because we're in the center of the United States. So one year we might go a little bit more with Ohio, the other year we may go a little bit more like the western states, but year in and year out it's felt to be temperate. So a temperate environment is characterized by low abiotic stress. Abiotic stress being weather extremes from temperature, moisture, solar radiation, humidity, everything that you think about as being part of weather. The reason I brought this up here is because Illinois is a really good place to grow soybeans because we have a good environment and we have great soils. So if you think about the overall environment that we experience, that's why we've had success with soybeans. When you look at southern Illinois on this chart just a little bit, I don't expect very many of you are from that far south, but just in contrast, it's a little bit lighter green, kind of a yellowish green. That's considered temperate dry. And southern Illinois is characterized by having less precipitation, and then they're also lucky enough to have highly weathered clay soils that don't hold very much water. So it's harder for them to grow a crop in some of southern Illinois area because of that kind of environment that's different than what we have in central and northern Illinois where we have our prairie soils. So, all right, for reference on the left-hand side, this is that 50-year average that I've just shared with you. And over here on the right is what we just experienced with 2016. So the colors on the map represent the environments experienced during the year of 2016. And if you look at the state of Illinois, most of it, except for part of the northern part, right in there, is considered temperate. This darker green is a little bit of temperate humid, but as a whole, it's about as close to the 50-year average as we've seen for a number of growing seasons. And if I think back to 6 months ago, I stood in front of the Pro Farmer group over in Bloomington right before they went on the Illinois leg and said, you know, we've had a really good year. I don't know how good our crop is going to be, but it's going to be good. And that was the case, wasn't it? So if you look again, what happens, we compare 2016 and then think about what the season was like. So don't need to explain it because you guys have just come through and it's easy to remember the most recent year, but think back a couple more years to 2014. Do you remember what it was like? I remember 2014 really well, and I'll tell this story on myself only because I was expecting my first child in 2014, and in the middle of the summer I dreaded walking fields with people because I was struggling to get through the field, and I was like, if it's hot, well, it was actually really nice for me because it was a temperate environment, excuse me, not temperate, high latitude environment that we experienced. This purple, do you remember 2014 was a little bit cooler? We had a lot more precipitation, a lot more cloud cover, a lot more humidity, and in turn, for our crop, what did that mean? We had more diseases. So as a pathologist in the room, Stephanie, we got to see a lot of things that were like, oh, this is fun to see these diseases, but knowing that it was going to hamper crop development and growth. But, so this is 2014 where we had a different environment and everything else shifted farther south. You can see that dark green is farther south and the temperate is just the tip of Illinois. But the purple is what Wisconsin and Michigan normally feel. So if you like the summers in Wisconsin and Michigan, 2014 was great. The reason I draw your attention to this, though, is again back to that solar radiation piece. We didn't have as much sunlight, so soybeans weren't able to capture as much sun. And if I remember correctly, they looked a little off color for part of the season because we just had so much moisture and lack of sunlight. They were a little pale. Go back with me a couple more years, if you will. Whoops, excuse me. 2012. I probably don't need to describe this to very many of you because you all remember what happened for our growing season in 12, but it was completely the opposite of 14, if you will. Hot, dry, just literally felt like a desert by the time we got to July across most of central and southern Illinois. And you can see by this map, we are now pulling this southern area up farther north, this temperate dry, and felt almost more like a Nebraska environment. So we had plenty of sun, but we didn't have the rest of the things needed to grow soybeans that year. We did have some late precipitation in 2012, and I can remember just from the crop model, corn may not have made anything, but some growers had soybeans that out-yielded their corn, right? That was the kind of season 2012 was. So we had all the sunlight we needed, but it still didn't make the soybeans the best that they could be. So the reason I draw your attention, this thing's not working perfect. When we're looking at our breeding programs as a company, we want to make sure that we're fitting things to the environments that you're experiencing on the farm. So the variety selection that you have in front of you matches what you might experience, whether that's hot and dry, cool and wet, or more of that 50-year average of that temperate environment. And what we do, this is just a map showing some of the locations we had this year, but we have 3 breeding programs, one in Champaign, one in Princeton, and one in Mascoutah for Pioneer. And we want to make sure that the variety lines that come out of those are consistent and perform consistently from a grower perspective year in and year out and from field to field. And so one of the things I want to show you with this backdrop is this past year we had 480 locations of what we call PKP locations. And those are the trials that are in their last stage. Maybe they're planted with a customer or on farm. They've already come through all the levels of research, spent a lot of time doing that, and this is that very last chance for us to put them in a plot. So these 480 locations range from an early 2 to a late 4 in maturity. You can see where they're spread out, the different maturities through here. But what I want to do is take these and use them as an example, so I'm kind of setting the backdrop up for myself. This chart takes those same 480 locations and plots out the solar radiation deviation in millijoules with each one of these lines. The 2015 is over here, and the 2016 locations are over there on the right. So the same locations are in 15 and the same locations in 16 as represented by those 480 dots. The thing that you'll notice, remember on the first slide I showed you that 2016 was a near normal season or perfect season for soybeans or for the environment. And look here, very few locations have a deviation from norm for solar radiation. So that means they're capturing ample sunlight. Then when you look at the 2015 bars over here to the left in comparison, you can see that they range from -100 to -777. So they weren't capturing as much sunlight during 2015 as the locations were in 2016. And why is this important, or I guess where am I going with this? One of the things that we're suggesting is by capturing additional solar radiation or sunlight, you increase the opportunity for more yield on a soybean plant. So let's take this another step. Adjusting the planting date and the soybean maturity, what it does is it harvests more light prior to the onset of flower or reproductive time frame. So you have more growth on the plant for potential nodes and for more flowers. It also helps you to avoid that period of drought stress or heat stress that we often feel in June or July time frame, usually July, August for soybeans. And so you've got most of your development ahead of that time frame. Whoops. So I took those same locations and we plotted them out by planting date to see what they looked like. So the blue lines again are 15 and the red lines are 2016 across Illinois. And here you can see the planting date starts around April and ends up middle of June. And then the red ones start in March and end early part of June. And what you'll notice, the yield as a whole of 15 is noticeably lower than 2016 with where the lines are. Then also the steepness of the blue line is maybe a little more because of the fact that it was being impacted more heavily by that lack of sunlight in 15 versus 2016. So what we're showing though is your earlier planting dates are capturing more sunlight. Yield is over here on the left, and you're noticing that yield is higher because of the reasons we mentioned previously. So we'll take it one step farther. You can adjust your planting date, but what else can you adjust from a perspective of maturity or variety selection? We took two varieties and planted them both at an early time and a late time. And what we did was our early variety was set for the area, so for instance a 2-5, and our late variety was a 3-5 or full season. We planted them early and then we planted them at a normal time frame for the given area. And this was done in 37 locations in Illinois and Indiana back in 12 and 13. And what we noticed, if you plant that full season variety early compared to an early variety planted early, we see an additional 7 bushel yield capture. The reason we're seeing this happen is because the plant has a longer growth period from vegetative and reproduction, so it can, in essence, capture more sunlight, more solar radiation, and has the ability to make more yield. When we take this full season variety and plant it at our normal time versus the early variety, we're still seeing an increase in yield from that more full season variety adapted for the area. Now, I certainly understand planting early varieties early or early varieties mid. We want to spread our risk out across the window because we never know when that drought period is going to hit. We don't know when we're going to get a late season rain. So as a grower, you want to plant more than one variety across more than one time frame because of spreading that risk. But as a whole, this early planting of a more full season variety is showing an advantage over the current situation. All right, I'll show this in one more level. We looked at this same kind of idea and seeing how much heat unit or growing degree unit accumulation was occurring prior to flowering of these varieties and from flowering to reproduction to see what impact that had. And you'll notice we have an early and a late maturity group that we compare across 6 different planting dates. I think this is page like 137 or 110 in the book that you've got in front of you if you do want to read the rest of it. But what we looked at were the average growing degree units that occurred prior to the onset of first flower, which typically occurs when we reach the summer solstice and the days get shorter to signal the plant to flower. So we have our April through July planting on both of these, and you can see the average GDUs that occur till flowering begins with an early or late planting is about static. So you see that these blue lines are fairly close across both maturity groups and across planting dates. So that's kind of this range of 700 to 800 for the 2 different maturity groups. But then the thing that's interesting, as you look at how many heat units occur from flowering through maturity, the earlier planting date is going to accumulate more than the later one, even though this window is about the same. So what happens, you can see down here, is it declines as you get to that later planting date, which in turn means the plant's getting, if it's getting less heat, what is it in essence getting less of? Less sun, less solar radiation, which we just talked about. The solar radiation in essence is one of the drivers for photosynthase and then eventual accumulation of yield in the bean seed itself. So if we're adjusting our planting earlier and we're adjusting to a little bit more full season maturity, you can again see the difference. This is the early versus the late, and the late has the ability versus the early to collect more because it's in vegetative growth up until the same time frame, but it has a longer window in reproduction. So either way, again, one of the levers you can talk about is your planting date, variety selection, as we talked about that list of 10. And with earlier planting, we realized that there are more tools in the marketplace today that you can employ, such as seed treatment of insecticide, fungicide, and all the other things that we can now put on our seed to help protect during that early or mid-April timeframe that we could potentially be planting soybeans. Now I throw this out there. I got a text a few minutes ago from my husband. He's like, the tractors are going to the field. Can I go out? You think it's okay? Should we be out? I'm like, it's the middle of February in Southern Illinois. We are not going to put a seed in the ground if we're lucky for 2 months, maybe 3. If you've ever worked in Southern Illinois soils, they kind of are challenging per se. So from that perspective, I would say early, but not quite that early in my opinion, right? We can wait just a little bit longer than that. All right, with that, I'm going to shift gears just a little bit. And this is a chart of Pioneer's kind of pipeline per se. I think Rob may have had something up a little bit earlier from the Monsanto perspective, and all companies have this, but I just wanted to draw this out and bring a couple of pieces of information to the plate. Pioneer started with soybeans just back in the 1970s when they purchased Peterson seeds, so not a terribly long time in the whole realm of soybean breeding and thinking about soybeans, but enough to bring varieties to the market. They started out back then and have moved forward. You can see this white line going up and trending with higher yield, productivity going up, and then this is time. Things like marker-assisted selection, a pathology lab, marker-assisted selection, being up there, and then the accelerated marker-assisted back crossing. So a lot of different things, technology terms per se, and then the last thing being impact, I think that's listed on this slide. But as a whole, they're spending about $2 million a day looking at product and product development, which, when you think about that, seems like a lot, but there's a lot that goes back into all of these products, whether it be at DuPont Pioneer or wherever. There's a lot of research that's happening to bring these products to marketplace. So one of the new technologies that we're looking at or have worked in is something called AYT 4.0. And we're going to be launching or have launched a new series of soybeans called the A series. If you're a customer of Pioneer or have ever been around any Pioneer products, you may have recognized previously things like M series, B series, T, and Y series. Well, we're moving on to now something called A series. And the reason that we did that for this year's launch was we're seeing a 2.3 bushel an acre advantage across 10,000 comparisons of the industry's most top yielding varieties with the technologies that we're employing. And so what AYT 4.0 is, just in a layman's term, I guess, to describe it to you, say I was a soybean breeder by accident, which I am not, but if I had that task in front of me and I had 50,000 soybean lines for selection for 1 year and I had to drop it by 90% down to 5,000, how would I do that? Well, before AYT 4.0 or before AYT, what I'd have to do is I'd have to look at all those lines and decide what I wanted to select for. So for you, I need to select brown stem rot. For you, white mold. Maybe for someone else, we're looking at Phytophthora. We're looking at SDS, and all these traits that are important as we grow soybeans. And what you'd have to do is determine that you need to find a field that was going to show all of those. And I brought this up in the last group, but I don't know if you've ever experienced this, but if you have a problem in the field, what's the best way to get rid of it? Put a plot in the field the next year. Because if you want to try and fix it, what's going to happen? It's going to go away when you go out there to put a plot in it. I did some work on my master's degree in SDS a number of years ago, and I was super excited because we had come out of several years of having just the most wretched experience with SDS. And I decided that that's what I wanted to work on because it was such a problem. And the first year I went out to put my plot out in the field, guess what? There was no SDS anywhere. It was just perfect. It had gone away, So anyway, from a breeder perspective, it's a challenge because you have to hope that the environment is present for you to be able to test and see all these things in the variety and lines that you're looking at. And if you don't see them, it's kind of a, well, we didn't know what it really did. Well, what happens now, we know where those regions are as far as BSR, all these different things we're talking about. We have an understanding of what the lines already have in them before we go out and try to test for them. So it has done something where it reduces the time from product being in the nursery to when it's an opportunity for you to select on the farm, down from the 16 years it's been to 6 or 7. And the goal is to get that down to a breeding cycle of about 3 to 4 years. We're looking at more opportunities and able to find more varieties faster to bring out to the field. So that is AYT 4.0, and like I said, that is a technology coming from us that would be then bringing stuff to you as an opportunity. So the last thing I want to talk about and I don't know where I'm at on time. Am I getting close? Okay, so I've got time to finish this up. Is something called Pledis. Anybody in the room heard of Pledis? One hand, a couple hands coming up, okay. Pledis is something that was introduced from Pioneer as something that has been driven by consumer need. Pledis is a soybean variety that has a different content of oil, a high oleic soybean. And right now, commodity soybeans have to go through a process called partial dehydrogenation. And when that happens, it makes the oil more shelf stable, but it also increases the trans fat. And what do you notice if you've been to the grocery store or to Subway or something and picked up a bag of potato chips lately? What's it say on the bag? 0 trans fat, right? Well, that's a consumer-driven health need, which makes sense when you think about overall health, but our soybean oil that we are producing doesn't fit into that very well, and it's been displaced by other oils in the market from a consumer perspective, like canola oil, sunflower oil, olive oil, palm oil, all these different things. So I kind of did a test of my own, and I was like, well, what do I have in my cabinet at home? So I pull it out, and I've got all the different things I just told you about, right? Because I'm a consumer, and I'm like, oh, this is supposed to be healthy. So I've got olive oil, canola oil, coconut oil, and I've got it all, grapefruit seed oil. And then I'm like, what about this that we fry with, right? I'm like, well, what is that? So I'm like, vegetable oil. Can you tell me what vegetable is in here? Okay, you guys got it right. Well, you're better than me because I had to flip it over and look. It is soybean oil, but I didn't realize that. I didn't know. So as a consumer, there's kind of a move away from this in some of the industry from restaurant perspective. So places like KFC and McDonald's are wanting this Pledis high oleic soybean oil because it helps them meet that consumer demand for a healthier oil. And then also, places like Nestle are already using it. So we talk about a lot of our soybeans going to food or feed, and maybe not so much for food use, but this is an application of some of the technologies coming out there that could help increase the demand for our Illinois grown soybeans, because as we said, great place to grow them. Why can't it be a great place to just use them too? So this Pledis high oleic soybean, you can see talking about the content of the oil here versus a commodity soybean. But the other thing that comes a lot of times when we introduce things, this is a trans gene. So when you introduce an outside gene to something, what's your first thought about what happens to the yield of that? A lot of times the thought is it brings baggage along with it, and that baggage brings the yield down, and then it reduces the overall desirability of somebody wanting to have or grow that product on the farm. Well, with this, we've seen that with the Pledis, it's going to yield at or the same as what we're currently selling, because they would be Roundup varieties. So that is a really good thing we don't have to worry about. They're marketing right now in Indiana, but the thought is there could be a market potential develop here in Western Illinois. Some of the folks in the rest of the group that I spoke to earlier asked a little bit more about that, but I'm not sure it's developed or it's all lined up. If there was, there would be a premium. Obviously, it is a closed loop right now where you have to have a contract in order to buy it, so that way we know it's going to the right place, because there are still some trade things outside of the United States with Europe on this, but we can utilize it in the United States. So again, this is just kind of an application of the technology and some of the things that are coming, along with some of the agronomic things that you can try and implement going into 2017, because I've had a few conversations on the farm in the last couple of months thinking about 17, and I've been surprised. A few growers telling me that they're going, almost 100% soybeans on their operation this year, or, upwards of 75% beans, and they've not been in that kind of paradigm before. So there are all these things that we talk about here in the last several years to raise the yield of soybean, and I hope those things are front and center for operations that may be shifting from having focused on corn and growing great corn on corn and continuous corn the last couple of years to going to soybeans. So anyway, with that, I have a couple of door prizes. I don't know, I've got a few minutes left, right? And then I'll answer questions. All right, somebody tell me what year Pioneer got into soybeans.
1970.
All right, raise your hand. Did you say 1970 back there too? All right, what I'm handing out, high oleic soybean oil Pledis multi-purpose lithium grease. Something new to try on the farm this year. Somebody told me earlier they thought it might be edible. I don't think you should try that. It does say on the side, I believe it says if ingested, if swallowed, do not induce vomiting. Keep out of reach of children. So I would recommend just for agriculture use only. So another question for the group. I've got a couple more. We started Peterson seed in 1970. What was the last thing on the chart? I'm on the same chart in my mind. What was the last thing on the chart that Pioneer referenced as being a new change in technology?
AYT.
AYT, what was right before that?
4G.
What? 4G? Is that what you said? Okay, not quite, but.
4G Lite.
All right, let's see if I can come up with one more. I'm thinking of a soybean variety from our company. It's my favorite one. Somebody name one.
M11.
There you go. M11s were a good one, weren't they? All right, I've got two more. Anybody in the room planted 34 TO7s this year from the company? Pass one back over there. I had one more hand over here. All right, guys, with that, I will take any questions that you might have. I should have planned this a little bit better. Was it your hand that went up? There you go. From the group. So, yes.
I didn't see anything. What are you guys finding on plant population? The sweet spot on that?
So plant population has been a big question the last couple of years, and I didn't put that in there. There's some of the research in this book. I guess my personal experience, not referencing the research right away, is I've seen a reduction in population as a whole because of the use of technologies like fungicide, insecticide. So we used to be starting at 150, and we're seeing it come and creep even closer to something like 125. I've got growers that I've worked with that are very confident in going out in their 30s and planting something even lower than that, but they know what they're going to have emerge. They always make sure that they've got the right window with soil temperature and seeding conditions right, following a time frame where you can get them all out of the ground. So I would say, based on your own planting practices and your experience, I could see that coming back down. We're seeing yields be very strong, much less than 150. So I don't have an exact figure,
Sure.
but I do feel comfortable moving that down. When I move into soils that are more challenging, or if you're going right in front of an event where you might have challenging environment, I don't know how many hours I didn't spend walking crusted fields in this area last summer. I was around the May time frame or something after Mother's Day.
Mother's Day.
Yeah, should I replant my beans? And I'm walking fields going, oh. Well, what happened from that perspective, if we'd had a few more beans, maybe they would have popped up. We wouldn't have had to worry about it. But in the end of the season or the end of that situation, we were fine because we had enough humidity that it softened that crust and all those beans came out. But back to your question, that's where I would be at here in central Illinois. If you move on to lighter soils, clay soils, I'm certainly not going to back off a whole lot because that's where I run a lot more replant issues and problems getting those beans out of the ground because the soils with high clay content will run together crust and you just don't. Yeah, and the beans break their necks coming up. And the university data from years ago says even stand of 100,000 will still give you yield. So anyway, other questions? Okay, well, you guys have been a great audience. And